Good morning. In this demo we are going to show a way or an approach to manage a full life cycle for cluster federation. In this demo we are going to follow the model that we see in this picture, where we have a management cluster or a control cluster, control OpenShift cluster, that creates from which we are going to manage federations. Could be multiple federations. In this demo it's going to be one federation. So we're going to create the clusters that belong to this federation, and then we're going to federate to those clusters some, but not all, of the namespaces in this control cluster. The idea is that we could then create multiple of these federations and federate different sets of namespaces, and then users can come to this cluster. They will have authorization to only some of the namespaces. They can deploy resources here, and the resources will be replicated in these clusters that have been federated. In order to this demo is comprised of several controllers and operators and resources. So in order to follow what's happening, we're going to use this map where all the involved resources are depicted, and there is also the relationship between who watches what and who creates what. I have already provisioned a set of clusters because it takes some time. To provision clusters, we use Hive, which is an operator that you can find developed by Red Hat. And this operator takes a cluster deployment object and creates a cluster. Right now it works on AWS, but in the future it will support other cloud providers. But because we want to be able to create a set of clusters or multiple clusters to federate together, I've added a new object called cluster deployment set. You should be able to see here. And then an operator watches this object and creates multiple cluster deployments based on the number of replica that you specify here. So it works very similarly to a replica set object or a machine set object. So this has already been done. Let's take a look at where we are. I have some commands that are already prepared here. So this is our cluster deployment set. We're going to take a look at what is inside of it. So we have the template of the cluster deployment, which you can see how it works in Hive, but basically in the Hive documentation, but basically it's all the information that you need to provision a cluster. The only specific attributes for this cluster deployment set is that it's the regions where the clusters should be spread on. So here we are creating three clusters, and they will be created in these three regions. We are going to ensure that the clusters do not have overlapping CDRs. So eventually, if we want to build a network tunnel between these clusters, that should makes it easier. And then we are going to register the clusters into the cluster registry in the same namespace where this object is created. So now let's see what happened. I did this about an hour ago, or maybe more, or an hour and a half ago. So 3 cluster deployments were created. 2 were provisioned successfully, and 1 failed. This is usually it's because I ran out of resources, some type of resources. Sometimes it is IPs. Because I'm sharing this AWS account with other people. But for this demo, 2 clusters is enough to see what's happening, so we're going to continue anyway. And we are also going to see that the clusters have been registered in the cluster registry. So we see that 2 clusters are present in the cluster registry. Now, now we can move to the other side of this map of operator. The other concept here that the cluster admin has to create is a multiple namespace federation type of object. The name may not be the best one, we can change it, but the idea is that we configure a federation that federates multiple clusters and a set of namespaces, and we also pass all the information relative to the type of federation that we want to build. So let's take a look at this object. So in this federation, we are going to federate this set of clusters, which are the ones that we have created with the cluster deployment set. So we need to pass where the cluster, where the secret is, what the admin secret, and the name of the cluster, and the name has to correspond to the name in the registry, in the cluster registry, which exists in this namespace, which is specified here. Then we want to deploy a global load balancer using AWS as the provider, and then this cluster will exist in the resources created in this cluster will, and this federational cluster will register themselves in this domain. And then for now, we are going to create the following federated types. So service deployment route, it is enough for this little demo to exist. So we control the federated types that the user can use. And we are going to federate all the namespaces that match this label or this label selector, which is federation equals demo. Right now in this cluster, there are no namespaces that match this rule. So the only thing that was created actually is just the global load balancer, which we can see here. It's this pod here, external DNS. It's the actuator that will configure AWS load balancer, and this actuator will be controlled by the federation control plane. So now we can create a couple of namespaces with that label. So let's do it. Okay, so now what is happening? Let's go back to the map. And what is happening is that for each of these namespaces that respect the label, a namespace federation object is going to be created. And this namespace federation object controls how the federation control plane needs to behave. And the federation control plane will be configured to federate only one namespace. You know that federation v2 or kubefed can work federating the entire cluster, so all the namespaces, or a single namespace. In this case, is going to be configured to federate only this single namespace. The other thing to note is that we are going to create all the objects that the federation control plane needs, so the federated type config, the federated clusters, and the domain, and all the secrets that are needed for federation control plane to do its job. And so there is no CLI interaction. So you don't have to do kubefed join to join the clusters, and you don't have to do kubefed enable to enable federated types. It's all controlled by this operator. So let's see what is happening. So we see that 2 namespaces federations were created in FNS1 and FNS2. These are the 2 federated namespaces. Let's see if the federated type configs were created correctly. So we see deployment, namespaces, which is needed by the federation control plane, routes and services for both federated namespace 1 and federated namespace 2. Then let's see if the domains were created correctly. So we have the domains, and finally, let's see if we have the federated clusters. Okay, so we can see that both federated namespace in federated namespace 1, both demo 1 and demo 2, which are the two clusters that are working, have been defined and are ready, which in for the federation control plane, this means that the cluster have been successfully joined the federation. So at this point, we can change our persona. We are not the administrator anymore, and we can become the developer. So just as a reminder where we are so far, as an administrator, we have created only two objects. We have the object that created all the clusters that we needed, and the object that defined the federation. Then somehow namespaces that were compliant with the namespace selector were created. And now, as a developer, we have access to we pretended we have access to one of these namespaces, and we create an application. Okay. So I'm going to run this command here. To create an application in FNS1, this creates a deployment, federated service, and a record, a service DNS record to be able to look up that service. So right now the federation control plane is working to create these objects in the federated cluster, and we can take a look if this is happening for real. So we see that we have a deployment, and we should also have a service in this is demo cluster demo 1, and so the service, we should be able to see the service here, and the same thing should be happening here. Yeah. So the federation control plane did its job, and the resources have been spread to the cluster. So at this point, it's where the demo has an issue. It's a specific issue between federation control plane, so the federation controller and AWS. The federation controller is not able to interpret what AWS returns when it tries to look up the service IP, and therefore it's not able to create the DNS endpoint. If we had this object, our external DNS pod that we saw before would see this object and would create an entry in the global DNS, and we would be able to interact with it with a command such as something like this. We could look up the application that we have deployed, and we could curl it, and our request would be load balanced. So this is where the demo ends. I cannot fix this bug, and we have to wait for Hive and OpenShift in general to be available in either Google or Azure to complete this demo.